2026 is without a doubt the year AI agents go mainstream. Agents like OpenClaw allow people to automate professional and personal workflows with simple prompts. But to be helpful, these agents need access: your GitHub token, Slack credentials, file system, entire network. By default, OpenClaw runs with the same permissions as you, meaning you're one bad skill or one cleverly crafted prompt injection away from potential disaster. So the question becomes, how do we run these agents safely? Today, I'll show you what that looks like on Red Hat's OpenShift, with container isolation, default denied networking, proper secrets management, and full observability. Before we get into it, a quick note on setup. Getting OpenClaw into OpenShift is made so much easier by this OpenClaw installer, which is actually built by one of Red Hat's very own, Sally O'Malley, and she's put together a full setup walkthrough video, which I'll link in the description, that can give more information on the whole platform and how it works. Today I'm going to be picking up from where that leaves off and focusing on the security and observability story. The first layer of protection is going to be the container itself. When you run OpenClaw on your laptop, it inherits your full user environment. On OpenShift, that changes immediately. Every container on OpenShift runs under the restricted v2 security context constraint by default. This isn't something you have to configure. This is just the default, as you can see here in the YAML. And then we can go ahead and verify that on our live OpenClaw pod right now. So here we see that restricted v2, and then we can also check, and we can see we're not allowing privilege escalation. We're having read-only root file system, run as non-root, all those nice security things that are just built into OpenShift. In a full production setup, you could keep inference in cluster 2 running your LLM via VLLM on Red Hat's OpenShift AI. So that way, sensitive prompts never leave a boundary you control. In our case today, we're using Granite via Models as a Service on a separate OpenShift cluster, which is just kind of a middle ground for this demo. It's still OpenShift infrastructure, just shared. If container isolation is layer 1, layer 2 is your network. When OpenClaw runs on your laptop, it can reach every service on your LAN, hit any public endpoint, and probe internal APIs as well. We fixed that with a default denied network policy scoped out to the OpenClaw namespace. We'll start off with this basic network policy that doesn't explicitly allow anything. Watch what happens when the agent tries to reach the Granite Models as a Service endpoint with this policy active. It's blocked. The agent can't reach anything that it hasn't been explicitly permitted to talk to. If it gets compromised via prompt injection, its blast radius is 0. Now let's add another policy with some scoped rules to permit traffic only to our Models as a Service endpoint, DNS, and MLflow, which we'll be using in a bit. So here you can see that network policy that we just added, and then we can navigate back to OpenClaw, ask it a question, and we'll get a response. Layer 3 is credentials. OpenClaw needs real access to do real work. The wrong approach is a .env file baked into your container image. If that image leaks, there go your secrets. Instead, we use Kubernetes Secrets mounted as volumes. The agent reads them at runtime, they never touch the image layer, and in the UI, the values are hidden. For production, you could back this with the external secrets operator, so the source of truth lives in an audited vault rather than in a YAML file. The last piece is observability. Here I've instrumented OpenClaw with OpenTelemetry and shipped those traces to MLflow, which you can see here. So these are the last 2 messages that we sent. And here's the full trace. In a simple chat with an LLM like what I'm doing right now, it's good for monitoring activity. But once you get into more complex use cases with multiple tool executions, the observability step can be much more useful and can answer that question, why did the agent do what it did? And back in OpenShift, we can correlate with live pod logs for infrastructure level signals like errors, latency spikes, anything happening on the platform level beneath the agent. So that's the full picture: container level isolation enforced by the platform, default denied networking with surgical egress rules, secrets management that keeps credentials off disk, and end-to-end observability with OpenTelemetry and MLflow. I hope this makes the move from a TypeScript CLI to a production-grade agent deployment much less scary and makes you feel more secure about it. I'll put all the relevant links in the description, and thank you so much. See you next time.